And what about the other presentation from?
Yeah, we still need to figure that out.
Do you have the keynote?
No, he has not given it to me. Okay, shall we get that? He wanted to use his natural use of the Safari thing. I guess we'll actually move that machine up so you'll see him like talking. You won't miss his presentation.
Sure. Yeah. Okay.
All right.
Sounds good.
Good to go. I don't know.
Let's get started.
This should be. To go.
1, 2, 1, 2. Good evening, everyone. Welcome to Mozilla San Francisco. Yeah, huge applause for Mozilla, who is hosting us for, I guess, the first time. Yeah, really the first time here. So thanks again. I know it was a special day for you guys with this Youenn's session. I guess it's the end of the 3 or 4 day of session, right? I would like also to talk a little bit about an event that happened recently. In general, it's hard to have some information ahead of time. So we had no information ahead of time, obviously. But the big news is, WebRTC is now 6 years old, as we mentioned at the previous meetup at Symphony. But we were not aware back in the days that it would be available on iPhone, iPad, Mac. And tonight we are really lucky to have Youenn from the WebKit community, and he will dig into the details for us. So we are really excited to hear from him. Talking about the agenda, we're going to start with a talk super technical. We're going to use the whiteboard to talk about the Firefox transceivers and the implementation. Sorry, the implementation of the Firefox transceivers. I already mentioned Youenn for WebKit. Then we're going to talk with Dr. Alex Gouaillard about the PERC standard and the implementation we've been able to achieve in a few months lately. And then we're going to finish with Nils, talking about how we can debug video issues with RTP logging in Firefox. Nils, do you want to add a few words?
Sure. Yeah, welcome to Mozilla. So this is as Arnaud said, the first time we're hosting this. The whole WebRTC team from Mozilla is here. So if you have like any hard questions once we're done with the presentations, there's like plenty of people to answer all of your questions. And yeah, enjoy the presentations. Yep.
The floor is yours.
All right. I got the blog. Oh, you want to pick the? Oh, okay. No. Let's see.
Can we do it on this one?
Yep.
Okay.
It's just like that one is streaming you live.
Oh, okay. Have to blog. Hi, I'm Jan-Ivar. I'm on the WebRTC team here at Mozilla, and I'm gonna. Byron and I are going to talk about transceivers. I'm going to be the good cop. He's going to be the bad cop. I'm going to mostly cover a blog that I already posted on blog.mozilla.org/WebRTC. I won't have time to cover the entire thing, so I'm just going to skim over a little bit to try to give an intro. Let me get a little bigger here.
Maybe if you want to click on this guy and share your...
Oh, sure.
Yeah, sure.
I have to check this one. You might have to, okay. All right, cool. So
we want to click on this, or not like the article as well.
Is it good? Yeah. So basically, the WebRTC spec is nearing completion. It's near 1.0. Under the hood, the biggest difference is the remaining obstacle to wire interop is that Chrome still uses Plan B. Firefox uses Unified Plan. I'm not going to cover that. I'm more of an API guy. But there's a lot of momentum now to try to finish the spec by the end of the year. So there's some planning if you're a web developer that you might want to prepare for, because the API is going to be slightly different. Show of hands, how many here knows about renegotiation? All right, good, cool. So basically, I was going to say, there's smaller changes like all the APIs use promises. You might know about that. But there's a larger change in the actual model, which is how do you manage media in a peer connection. So, and if you've only used Chrome and not followed the spec, some of these changes in the API might surprise you. So, and the reason is that the peer connection API has endured 3 design iterations on this topic of media management. As a result, browsers today implement a snapshot from a different point on the timeline of an evolving spec. So the 3 main stages in the design have been stage 1, which is add stream and remove stream, which is what Chrome implements today. Stage 2 is add track, remove track, and sender replace track, which is what Firefox implements today. We also implement add stream. We do not implement remove stream. And stage 3 is add transceivers, which we'll try to cover here, which also covers early media cases, which I'll get back to. Basically, each of the early stages were leaky abstractions on top of later ones, which are on top of the SDP. That's why we iterated on it. So the easiest to explain each stage as they happened. Stage 1 is the oldest model. It's no longer in the spec. And it starts to break down when we want to manipulate individual tracks inside a stream, like a media stream containing a video track and an audio track, for instance. Let's say we want to join a WebRTC call face muted. We don't want to show our face right away. So here's a simple fiddle that lets us add and remove a video track to an already established audio call. So basically, I can run this quickly here. Oh yeah, maybe I shouldn't do that. What's going to happen? All right, so I'm sharing my camera here. I check this checkbox, and I get the video, and I uncheck it. It's a little bit of a delay. That's actually a bug. Don't mind that. And it goes away. So we're going to look at the, this is just a local loop test. We create 2 peer connections, 1 and 2. We get the stream from a media stream from GUM. We remove the video track, and then we call add stream just with the audio track in it. And then we have a checkbox. So when we check the box, we call, we actually have to, we add the track to the stream, video track back to the stream, and when we uncheck the checkbox, we remove it from the stream. And that you'd think might be enough, but we also have to remove the stream from the peer connection and add it back again, and that's just a kickstart peer connection and tell it, hey, something happened, do a renegotiation, and that kind of sucks. So, and it's also what we call action at a distance, and that you may not have expected it to, that adding a track to local stream should suddenly trigger sending of that extra stream, and that, you know, that might be surprising. So it's not a good API. And on the remote side, we use an on-add stream event here, and we hook up some listeners to the remote stream to figure out when tracks come and go. So to solve the action at a distance problem, we basically pivoted to tracks, which is stage 2. And this is what Firefox implements. It's still in the spec. And the pivot to tracks makes our code a little simpler in that instead of initially we just add the audio track to the peer connection, and the checkbox case is very simple. When we check the box, we add track the video track. When we uncheck, we remove track the video track. So it's a lot simpler. It also has some benefits. By the way, add track. If you look at WebRTC samples, you'll find that they have actually pivoted to tracks as well now, thanks to the adapter.js polyfill. So that's a good snapshot of what's to come. And also, let me see. The other thing that wasn't too obvious here, I should have pointed out, add track returns a sender object, which is a handle to the thing you're actually sending. And then when you call remove track, you're actually you're passing in that handle again. And the sender object is one of the main benefits here. We have dedicated sender and receiver objects. It means we have a control surface for each media transport separate from the content that goes over it, the track. And that means we can do things like call sender set parameters to downscale video. We can call sender get stats, receiver get stats, stuff like that. And it also has replace track, which is a powerful thing in that we don't actually have to renegotiate, which is expensive, just to change what we're sending. We can just send different bits over the same pipeline we already have. So replace track is very powerful for that. So this model has about a lot of control, but there's still an abstraction in the sense that when people were using this for real websites, there's still things that were hard to explain if you just understood this API. So basically, ICE, which is the thing that allocates media ports and opens firewalls, they're bidirectional media ports, and there was no way to know which sender and receiver go together. There's no clear reuse model, which means if you actually remove track and then add track, remove track and add track, you're actually creating new M lines for each add. And an M line is basically a line in the SDP text file that starts with an M. So, but it's still a resource. We don't want to use too many of them and allocate unnecessary ports. There's also some problems where stream IDs are replicated remotely, so, and they can actually collide in rare cases with if you have multiple people calling the same person. Let's see. So we have stage 3, and the add transceiver model. It solves all those problems, and no browser implements it yet. And there's one more problem, which is that a lot of times we'll call setup times being critical. Some users wanted to send media early, which means they don't even want to wait for the two-way handshake negotiation to complete. They want to send media as soon as they can. And the first main difference with transceivers is a transceiver is just an object that naturally groups a sender and a receiver. But what's less obvious when you create a transceiver, or indeed when you call add track or add stream in this new model, which no one implements yet, you get all 3 objects at the same time. And that, well, that's fine. But you might wonder what happens. So that means if I call add track, not only do I have a sender, I have a receiver already, and that has a track. What if I take that track and put it to a video element and play it now, right away? And that should work. It would show black, it would show silence until something actually later arrives on that track, but it's there. And that's very different from what everyone implements today, where remote tracks are basically created at such remote description. So, and still there's a lot of stage 3 tries to at least accommodate the earlier stages and make it work. And I think Byron's going to point out some of the shortcomings there. And so here is the last version. You'll see we have methods add transceiver, where we can say, for the auto track, we can say direction send only, and we can add the video transceiver right away, which is new. We just say direction is inactive, and then when we check the checkbox, we now change to we call set direction send only, whereas before it was inactive. and then we uncheck, we set it back to inactive. So now there's a direct mapping between a sender object and the remote track. And the remote track doesn't really ever end. It gets muted because unlike add track and remove track, which created new M lines, this model actually reuses the existing M lines, so that's why tracks are only muted, because it's only temporary. And so these models are slightly different. The main benefit here is that it kind of matches how things really are underneath, that you can use an M line as many times as you want until you call transceiver stop. There's also some symmetry advantages. If I go back to look at the checkbox case, I skipped over that. Not only do we set direction to temporarily to inactive or send only, we also call replace track. So, and that's quite neat because we could have just used replace track. So if you don't care, changing the direction is only for people who care about not sending any bits at all. So you could actually just disable a track, it would still work, and you can have the same effect without any renegotiation. You can also do the renegotiation piece if you're concerned about sending absolutely 0 bits, which could matter in a multi-person call. And the fact that these two ways of working are line up like this is a good sign for the API, I think. I think Byron's going to touch on transceiver also has a MID. It's an MID that is the only surefire way to correlate remote tracks with local tracks now, because of the new way, because the receiver track is created so early now, and track IDs are immutable. That means the track exists right away, and there's no way that that ID can match what was on the other side, because set remote description hasn't happened yet, and we're not allowed to change it later. So I'm gonna skip over this part, but basically, track IDs are host. Stream IDs we hope to save, and that they're not surfaced to JavaScript until the track event actually fires. And I think with that, Byron, if you want to take it from here.
All right. Can we? Yeah, we need to pull this down. You want to get your? Oh, is this like the Podium's laptop?
Well, no, it's like live streaming.
All right. So in one sense, I've prepared for this talk about 30 minutes. In another sense, I've spent the last 6 months preparing for it, trying to implement this. And there are some gotchas. I'm just going to talk very briefly about this. Okay, here we go. So there's 3 big things that I want to talk about here. This is going to go pretty quick, but you know, don't worry too much. So Jib touched on this just a moment ago. Remote track IDs do not mean anything. Right now with Firefox, we do our best to make sure they match on each side. So a local track on one side, its identifier matches the remote track on the other side. Not possible. There's a couple of reasons. One is a signaling reason. The MSID attributes in SVP cannot change during the renegotiation. It is not allowed anymore. So if you do a replace track, you do anything like that, they have to stay the same. You have to do And of course, the second reason is the thing that Jim touched on is you're allowed to see the remote track before you've seen any signal from the other side. So the IDs can't match. There's no way to pick. So use transceiver MID. Sorry. Small. Okay, next thing. Add track is magic. Now. So, there's 2 ways that you can create a transceiver. One is implicitly, well, there's more implicitly by calling AddTrack. And a transceiver so created will automatically kind of buddy up with the inlines in a remote offer. So if you create a transceiver on your end with AddTrack, and then somebody sends you an offer that has the same type, it'll say, aha, we'll just latch on to that. And that'll be the transceiver for the corresponding transceiver on the other side. If you create one with that transceiver, you do not get this special property. I noticed that this was a little bit confusing, so I went and talked to Tim Bergstetter. And he said to me that the intent was also to have this special property be kind of latched onto the transceiver when you set a track by calling the track. More on that in a moment. That's not in the spec yet. So here's an example. It's kind of the old model. Both ends use AddTrack, and they do a renegotiation. You get one transceiver on either side, sending and receiving audio. However, when you use that transceiver, they do not have this special property that allows them to match up automatically. And so the answerer does this. Offer answer happens. The transceiver it created does not get to pair up. Negotiation is not complete. It has two transceivers, one with an active sender for the sender side, one with an active receiver in it, and one with a sender in it that it needs to negotiate later. So two transceivers and a negotiation. Here's another example. This one works because the offer uses add transceiver. It doesn't have that magic bit set, but it doesn't matter because it's the offer. The answer is use AddTrack. It has the magic bit set, and so it all works in one negotiation. It pairs up like it's supposed to. But if you switch it around and you do it the other way, with offer using AddTrack and answer using that transceiver, it does not work. You end up with a similar situation. So remember how I mentioned earlier that AddTrack can update sender track on pre-existing transceivers. Sender track has to be null. It's pretty sensible. The track has to be the right media type. That's also very sensible. And the sender is never sent any RTP, which that's pretty sensible too. Until you start thinking about it. So, yeah. It's only when your sender has actually sent stuff. And this depends on how negotiations have gone in the past. The other end may have rejected your offer to send, in which case, if you null it out with replace track, doing AddTrack later, and set it otherwise. So, offer receive. Kind of an old thing. It's also matching out. So let's say the offer creates an offer to receive audio true. That would mean we would set up our SVP like a receive only section so that the other end can send us stuff on the first negotiation. So this causes a transceiver, a receive only transceiver to be created automatically, implicitly. Cool, huh? You guys are thinking this is probably not going to be cool. So let's say the offer changes its mind about that offer and calls create offer without. Transceiver is still there. It's been created. There are no takebacks here. Offer receiving is sticky now. So watch out for that. And that's all I got. Those are the big gotchas that I've encountered trying to implement this stuff. I guess watch out for that. And That's me. Any questions?
Byron, I think you have been making of a blog posting that you are eventually a two blog with the gotchas from Transceivers.
I love gotchas. I mean, I love the long-standing tradition among developers to find humor in things that hurt us.
Do you think that should be improvements in the job? So that the number of tasks.
You know, every time you try to do that, it's so much worse. So, I don't know. I don't know the answer to that question. I mean, maybe we try to shore up some of these gotchas, but I mean, they're trying to add this new concept based on the API with all the side effects and keep the old API around and have it trained to behave the way it used to. But I don't know. I mean, it's kind of a mess. And I only noticed this stuff when I started trying to implement it. And it may be too late because the IETF path is in last call or has gone through last call at this point. Like they're about to wrap. So we're kind of probably stuck with it. So be ready for a little bit of integration difficulty when this stuff finally happens. And we're going to try to keep things or keep compatibility problems to a minimum. So, for instance, you mentioned earlier the fact that MSID attributes and all that changing in that. We're going to forget that. Like, Firefox is going to let that slide if it happens, because if we don't, we can interrupt the versions of ourselves. So, we'll do our best to kind of smooth things over, but it's been too often. Replace track. So right now, Firefox kind of tries to make the IDs line up when you do a replace track. We don't fire negotiation needed, but when you do get around to renegotiating, the new IDs will be in there right now. That will stop being the case because of what's expected for visit. And so that will be a change. If you were relying on that before, you'll have to do something. Otherwise, I think replace track should just work. As long as you're just using add track and replace track, and kind of like don't mess around too much with that transceiver, it'll function a lot like it used to, with the exception of like offer to receive, which gets a little. This all applies to the Transceivers API, and it's a major rework that I've been working on for probably the last 6 months. And it's going to cause problems. And so we're going to try to land it early in the ID cycle so that people have time to compensate. And as long as you're using add track and replace track, it'll probably be mostly okay, which you're going to be, right? Nobody's going to be using that transceiver. Offer receive might cause some weird stuff to happen, but just be on the lookout. It might behave on.
I would add that a lot of these side effects come from the later stages trying to be compatible with the other one. So if you want to confuse yourselves, use them all. So I would say if you stick to the transceivers only, I think most behaviors you'll probably find are internally consistent. So it's more that, it's unfortunate that, we had to have 3 different versions, iterations basically happen in the open. Sometimes, you got to implement or define.
It's complicated, and it's been a leaky abstraction all along, and it's just gotten less and less abstracted as we've gone.
Any other questions? All right. Thanks, guys.
Okay, I'm Youenn, regular WebKit contributor, acting very happily on WebRTC these days. Maybe WebKit, I don't know, but today it's WebRTC. So I'm very happy to talk a little bit about WebRTC and WebKit, and mostly related to the iOS and Mac ports. So I don't know if many of you were there at Symphony latest WebRTC meetup. There was a guy that did a presentation and said, "Hey, I've done like WebRTC for 30 years." And I was like, "Okay, from my side, it's closer to 30 days than 30 years, but that's okay. I'm late in the game, in the party, but that does not mean that I can provide something that might be useful." And that's something that is interesting. If you happen to be at the end of the party, maybe you will be able to be a little bit cleaner, meaning that maybe you will not be adding support for add stream, remove stream, all of that stuff that these people actually talked about. And this is something that might actually happen if you plan to support WebKit, meaning Safari on iOS and Mac. Be prepared to not use stream anymore. Instead, use tracks. So a user usually wants to take the train. So they really don't care about individual tracks. But on your side, since you're building applications, you care about tracks. So they said something's rare. It's really true that you're manipulating tracks and not streams. So forget about streams. Let's go with tracks. Let's go with transceivers a little bit. So it's not totally true that transceivers are not there. Transceivers are partially there in WebKit type of tree. So if, for instance, you actually want to do receive-only SDPs, we do not support offer to receive audio. We do not support offer to receive video. Please use @transceiver. It will not be perfect. It will not be standard because Safari and WebKit are not using Plan B. They are not using the unified plan for SDP generation. They're using the old Plan B. That's sad. That's life. But still, in terms of API, we are closer to where we want to be at the end. So that's good. So let's do. I wanted. So I did some questions, and at the beginning with the team, they didn't think that WebKit and WebRTC was the real thing. So I had to do a demonstration. So I will also put you, but maybe WebRTC is really in Safari. So let's go to this website, WebRTC samples. It's ready. Let's start something like that. Oh, that's a prompt. It's brand new. It's model. Everybody likes model. That's true. Users actually want model dialogues because they will not mess up with things. They will see that and be able to say aloud, let's say. And that's me. Now it's the big thing. I'm very excited about it. Let's call myself and see what's happening. Oh, what's happening there? I don't know. Oh, it's there. So that's a trick. What is happening there is that I'm actually capturing, I'm taking the video stream and putting it into Canvas and using JavaScript to actually pixelate video. Then I'm using capture stream to actually output their video. Now there's no pixelation. Why? Because simply I replace the track used by Pandas for the video track. Why have I done that? Battery life. So in a sense, capture stream is very hurting battery life. I just wanted to use for 30 seconds. The first 30 seconds, because maybe I'm very shy, and in that case, I don't want to be seen in the beginning. I want to see the other before. So that's why I've done that. Maybe it's, I don't know, maybe some web developers will want to do that. But be aware that for battery life, getting the real stream and putting it into peer connection is great. Doing something else will be less good for battery life. So that's it for the tracks. There might be a blog post about it. So you could try Transceivers things. It will not match the spec, but that's okay. So now, because we were late in the game, we could also do something differently. And some people there might be disappointed that we did it differently, but it's for the common good. So we wanted to have people actually, we wanted to leave some privacy to the user. And WebRTC is a technology that has deep privacy impacts. Like it allows the website to know your face. It allows the website to know your IP address. So these are things that are important to us. So we did something differently, meaning that if you use WebRTC on Safari by default, no post as candidates will be given to the web application, meaning that in many cases, your local IP address will not be given to the web application. Another demonstration. It's another examples where we are actually trying to gather candidates. There's just one. It's a self-reflexive one. As you can see, there's no host. To prove that we're still able to do that, we can go to some early menu item, disable candidate featuring from WebRTC. And do the same thing. We have the candidates. Oh, we have host. So yeah. So now I probably know that I can be tracked. So by default, this will be that. So only public IP address in TSM. When the user is actually authorizing the website to get camera access or microphone access, then we think that in terms of trust, the user is okay leaking privacy to the website. So in that case, we feel that there's no harm in actually providing these IP addresses. The main use case we want to avoid is actually advertisement people being able to track you. This is a reality. This is the first crash I had to fix on a real website with WebRTC when implementing it. So, yeah, it's working. So there's another private property here that I want to talk about, which is get user media. So, so there's a prompt there, as you can see, and you will be able to allow it once. When it's done, you're on the same web page, you can ask for it again, meaning that it will be persistent for the lifetime of the web page. If you're actually reloading, you're back to that. You can, of course, ask the user to right. Now, let's say that another web page wants to actually grab camera access. That's fine. Another prompt there. We're getting it. Oh, but wait, this one is black. So that's another device. Look for unmute events. look for unmute events, because this will tell you whether something happened, either on the system there's no more availability of the camera or of the audio, or it's just another tab that is grabbing the thing there. Of course, you can ask the UI, so the user can actually try to do that. And there you will react. So that's how it's done. We welcome feedback, because it's the design we have currently, but maybe you will have better ideas than us. So if that's the case, even if that's not the case, if you have like crazy ideas, come to us, and maybe there will be something great for you. Okay. A little bit about autoplay policy now. So how many people knows about autoplay policy in iOS, Mac? Yeah, not a lot. Okay. So usually when you have a video that is autoplaying with sound, it may be great. It may be really annoying if you're in the subway and suddenly there's big sound going on and everybody is looking at you. So autoplay is something that is trying to actually stop websites to do. In the case of WebRTC calls, that's really counterintuitive, because most of WebRTC sites actually, whenever the stream is coming, they want to display with sound. And also the user granted get user media access, so he clicked on it. So he did a user gesture. So there we decided to relax a little bit the constraint. So normally you should not have an issue with autoplay policy. This is software. There are plenty of bugs. We welcome your feedback. Okay. So I don't know who will guess what is the subject there. Difficult. Compression. Yeah, that's a tough subject. So as many of you know, we are supporting, and we are very proud to support Purpose, JSON 21, and all the stuff for audio. I will not talk about video. 264, yeah, that's it. Seems great in terms of battery life. It's all hardware accelerated, so it's very good for new users. I know that for many of you it might be difficult to use, but still there's a real user benefit in terms of performances, and this is really something that we care. Okay, now let's say, so how many of you are developing WebRTC applications? Oh, yeah, so you might be interested in debugging tools. Yeah, okay, but we don't have a lot. we have this smiley face. We have basically the console log that will log some information that is already available to websites. We also have servers that know a lot about it, so that's one thing. And we have Wireshark. Yeah. Since there are some developers, you might be interested into testing. And this is an important subject for us, because we like writing software, we dislike writing tests. We are very bad at tests. And we know that you are very good at tests. So we try to provide you all the necessary flags that allow you to integrate WebKit into your continuous integration system. So let's look at some of them. So what I will present here is the famous debug menu that nobody knows. But there might be in newest releases, there might be something going into the developer menu, which might be there. So let's look at media flags. You can enable not capture devices. And there, let's see something. Wow, great. It's synchronized with the audio. So you can do things with that. It's very repeatable. You can do whatever you want. It's great. And the good news is that there's also a back camera. And it's gray. It's not black. So we have that. We have the ability to allow media capture on secure sites. Meaning if you plan to use HTTP on your continuous integration system, then you're good. So you can use it. You can also allow camera to allow on all websites. So then you will have no problem. There's also a way to do that through scripts. So you can probably, we hope that you will be able, with all those things, to integrate Safari and WebKit into your continuous integration system. And that will be great because you will improve it, you will find bugs, and we will fix them, and we will not try. We will write tests. Yeah. But anyway. Yeah, there's Safari driver / enable, which is available in ICRC2. Right. Last Monday. Okay. So that's my last slide. There's plenty of meanings there. I would just pick one, which is performances. We care about performances. You care about performances, even if you don't know it. And we know that on small devices, it might be difficult to have like 100 of video streams coming in and being displayed HD. We might not be able to provide the efficiency there, but we hope that we will provide sufficiently good performances for user basis. So you are responsible to also monitor that, do good things so that your battery life, the user battery life is great. The temperature of the iPhone is great too. These kind of things. We hope to be able to improve the support for things that you might need to do that, either within WebRTC or in some other ways, like new APIs for you to monitor what's happening. If you're interested, let's talk. That's Youenn. Any question? Yeah, I wasn't clear. Okay. So let's say that you have Safari, you press the home button, and Safari is in the background. So there you want the unmute event and unmute event as well. Because if you're going to background, then the video camera will be set up, black frames only. Audio will still be available, and you will see some red bar so that the user will know that it is recorded. That's what we have.
So you were talking about the rights and stuff. That sounds like you're mostly implementing the identity data, like, you know, I'm not seeing anything about selecting only those bits that are critical wrapped. Are you guys doing that?
Yeah, that's the plan. There may be bugs, but that's the plan.
Okay, cool.
So what is the current state of the data channel implementation?
Data channel should be working. Yeah, the WebRTC data bio sample is not working because we are not providing as candidates, so that the local loop is not working. The same example with the same example with two browsers will work. It's true that data channel between two devices in the same network behind that, they might not be able to connect without term, which might be a restriction for some applications. Maybe there are better APIs in those cases, I don't know. Maybe there are cases where we should do that. There's future, there are new releases in the future, So maybe we will change things there. I don't know.
Is it using the user FTP library from
So underneath, yeah, I should mention something. So underneath, we are using WebRTC that Chrome is using. We reused a lot of the code that Google implemented into WebKit in the early days where Link was not yet a thing. Then the WebRTC and WebKit team, meaning Ericsson team, Gouaillard team, Dr. Alex, did revamp a lot of this up to Transceivers and that track. They did a lot of great job there, so that we were able, when implementing that, to just implement the latest API using WebRTC.
What's the status on advance for ways handle that for external media?
So currently, there's no support for it. If you think it's an important use case, and you might think it is, please file a radar saying I really want it.
I noticed using online JavaScript sites like this or Code10 that KBC is not working, and I think it's because of the
So if the plan is that for iFriends that have different origins to not be allowed to call get user media because in terms of prompt, we are not to have something for that. If it's not the case, like if it's an iframe that is same origin all along up to the main document, we hope it's working. If it's not, we'll try to fix it in the next release.
Okay, I think they use it's a different origin, but they allow the same origin.
Yeah, we are not yet supporting that. It's pretty new. That might be in the future something we can do. Okay. Thank you.
All right. How many of you knows what perp means? Because it's written on the slide. No, because you are technically involved in the WebRTC community and the application. That's awesome. So perp stands for Privacy Enhanced RTP Conferencing. And I will walk you through a few slides that explain to you the use case that I've been facing in the last 2 years. That's something. And then, luckily, I have Dr. Alex who will dig into the details of the packets, of the bits. You will love that a lot. The default use case with WebRTC in general is P2P, right? You get the best user experience, you get the best quality of audio and video because you are using UDP, you are in the happy path, that life is beautiful. In terms of encryption, obviously the application layer is over HTTPS. If you want to add an additional layer of encryption, then you can do like we do at Symphony, our own encryption in JavaScript on the client side. These RTP packets are fine. They just go from one endpoint to another, and everything is end-to-end encrypted, I would say. What about Turn? Turn is great, especially if you are behind a firewall, like a lot of the enterprise world users are. Turn is great because it doesn't terminate the encryption, and so it's still an end-to-end encryption. The SRTP packets go through the Turn server back to the user. So if it's Alice and Bob, you are in a situation where the packets are end-to-end encrypted. The application layer is pretty much the same, exactly the same, I would say. Now, what if you want to scale your solution in order to support like 10 participants, 20 participants? What if you want to add recording on the server side? For all these reasons, you need an SFU or an MCU on the server side. And then you look at the implementation, obviously. So you will find a bunch of them. Some of them are proprietary, some of them are open source. But in general, they haven't made the effort to kind of making sure that it's end-to-end encrypted. So what they do actually is they terminate the encrypted communication, they duplicate the packets, they mess around with the headers, and that's really bad. They have potentially the raw media in the clear on their servers. So whether you are using a third-party provider or whether you are hosting and you are a provider itself providing service to your customers, you are in a situation where potentially the content is in the clear on the server side. You really want to avoid that, and it was one of the challenges I had to face and find a solution for that at some point. So, yeah, why not going for a double encryption, right? You do the encryption twice on the client side, and then if the keys are these, then you are pretty much safe. But that's the theory, because if you look at the implementation, there is no implementation today of such mechanisms. So in this topology, you're good. The SRTP packets are encrypted an additional time. So the media server see regular packets. It's good for backward compatibility, but the packet itself is still encrypted another time. If you want to do this, you need to obviously find a client that supports this, find a server that supports this. So basically, the entire chain to be modified. So that's exactly our use case in the fintech industry. The clients are getting some keys from a key manager. In general, it's on-premise. And this key is used for the not hop-by-hop encryption, but for the encryption of the content itself. So we are really proud to announce that PER, that was an ITF alive, but with no implementation for many months, with the effort of GT, of Dr. Alex, of Symphony, and many guys around in the resource community. We managed to have the full chain implemented. So the client side with Chromium, the server side with Janus and Jitsi, and we have a demo that we might share afterwards. Any questions so far? You guys love encryption and double encryption? You are excited by it? Or you prefer to see yourself twice? Okay, so let's dig into the details. Can you go ahead? No, you can do it.
All right, so Arnaud approached me around November last year and said, hey, I have this crazy idea. Do you think it's doable? And the crazy idea was to do the double encryption. So we started to look around, and there was a working group named PERC, Nils, who is one of the chairmen today. So if you really, really want to know what the real PERC is about, he's the guy you should ask. And we said, what can we inspire ourselves from the work that group already done, because those guys are smarter than we are, to achieve what we want to do that might be slightly different than the use case PERC was originally made for. So there are a lot of documents within the PERC working group. There are, I think, 4 of them, if I remember correctly, 4 major ones and a few smaller ones that we produce in the meantime based on feedback for implementation. We were mostly interested in the double encryption part because we already had within the bank infrastructure the key management part, point number 1. And point number 2, the client was in a trusted environment. So the connection between the client and the key manager was not a problem for us. Those 2 points are a problem in general, and they are addressed by other means within the PERC working group. So that's the reason why we call it PERC Lite, because we took a subset of what the PERC working group had proposed and adapted to our own use case. So we don't want to abuse the name PERC here and make it clear from the get-go that we didn't implement everything. And we just try to give feedback on the part we implemented to them and show you our use case and how we implemented it, maybe to give you idea, but without any commitment for it to be a complete PERC implementation in the first place. So if you go into the way it works today first to identify the problem, this is how it works. This is what an RTP packet looks like. You have a header that represents a lot of things, and then you have a payload that represents the media. And the payload can be any kind of media, it can be embed in that case. And so if you look at the standard side of things, you have one set of documents that describe RTP, whatever the payload is. And then for each type of codec, we have a specific payload document. So you have the VP8 payload, or fully soon the VP9 payload, the document and so on and so forth. So the game is to have an engine that generates the RTP packet, and then to adapt the payload depending on the encoding and decoding. If you look at what the secure part of it is, so the SRTP packet, you actually take an RTP packet and you're going to do 2 things. You're going to encrypt the payload, so nobody actually understands the contents, and then you're going to leave the RTP header intact because you need the information there to route the packet or to deal with the packet, right? But you still don't want people to tamper with it, so you're going to authenticate the RTP header and the RTP payload together. So on the reception, you will be able to compare what you received with the hash of what was sent to see if anything was modified on the one, right? So people can see it, people can modify it, but you don't know if they do. So as another representation, which is on the right-hand side, is the one we're going to use later on. So you see the encapsulation between the RTP header and then the encrypted payload. You have a signature, so it's a simplification of the horizontal part you have on the left-hand side. So if you look now, what happened with the NSFU, the client will send you an SRTP packet. You have the red key at disposal. You're going to decode it. And you're going to use information that is, in that case, in the payload descriptor to duplicate the packet and route it. And so you need to do that to relay to multiple parties. When you receive only one, you need to be able to copy the packet around and send it to the right place. Right? So this is what's happening with WebRTC today in an SFU. It terminates the encryption, so the SRTP packet becomes a raw RTP packet. And it's going to read some information not only in the RTP header, but in the payload. So it needs to have access to the payload raw, right, and encrypted. So what PERC double encryption says is that, well, you can just do that twice with 2 different keys, right? So you have an RTP packet, you encrypt it once, you have an SRTP packet, you encrypt it twice, you still have an SRTP packet actually, correct? It's just another onion layer, and this is what it looks like with respect to the 2 different keys. So the first key, the inner layer, is end-to-end. The second key is the hop by hop, so it's going to be terminated by the SFU. I'm a normal SFU any modification. When I receive something like that, I'm going to terminate the first encryption, and I'm going to bump into an encrypted payload. And so that information I'm used to use to route my packet and do my job is not accessible anymore because the VPA payload descriptor is in the payload, so it's encrypted. Only the RTP header is not. So I can't do my job anymore. So what can we do to actually modify, have the minimum amount of modification in the SFU and in the client to make that happen, beyond the double encryption itself? Well, you can actually take the information you're interested in, that is in the payload that's going to be encrypted and accessible, and put it in a header, which is not encrypted and is going to stay accessible all along. So that's the part you do on the client. You copy the parts that is in the payload descriptor and put it as a header exception in the non-encrypted section. Fortunately, there was already a draft of a specification for that called frame marking. That was not only doing that, but doing that for simulcast, for SBC, for everything. That was beautiful. So we just took it and used it. Thank you. So I just did the implementation in WebRTC of that part. I did a very small part of the implementation. Most of the implementation of the double encryption as it is today was done by Sergio Murillo. That some of you may know from the blog post on WebRTC Acts about a few things related to WebRTC. So once you've done that, you make that information accessible. But the SFU is still looking in the same place, right? So you have to tell the SFU that it should now look at that specific RTP header extension for the information it used to look for in the payload before, right? So that's first the GC team, and now since this morning, the Janus team implemented that. So basically support for the frame marking extension. The key point in what we propose, and that's why we call it PERC Lite, is this is the only modification you need to do in an SFU to support double encryption, which is very, very lightweight. That's just an additional header extension. Both GC and Janus were able to do that in a couple of days. All right, and then you can do exactly what you were doing before, with the difference that at no point in time, the media server can access the raw media. Right? And that's the key difference. No, you do not trust the media server. So that was conceptual. Now I know today we have a more technical audience. So I'm going to share some slides that Sergio specifically wrote for the working group. So it's a little bit more technical. Bear with me. I'm not sure I understand everything, so be nice on the question, but I will try my best. The idea was to have a minimum possible implementation of double encryption without taking care of the key management or the connection between the client and the key manager, right? We wanted to have minimum impact on the SFU because otherwise people will not adopt it. And we wanted to investigate if that original idea of just doing twice an encryption in a row, applying SRTP twice, was actually viable in practice. And unfortunately, the answer was no. So in practice, if you do a double encryption in a row, like it was proposed originally, you have some mechanism that become broken, namely retransmission, forward error correction, and to RTP at the packet level. So we had to come with something slightly different. We also tried to investigate and find a use case that was really justifying supporting end-to-end header extension, because to support end-to-end header expansion imply additional header management mechanism that in PERC today that is not in what we implemented. And we couldn't find any of such a use case. So neither the GC team, nor the Janus team, nor ourselves, not anybody on the mailing list, as far as I know, as of today, could provide a use case that was definitely proving that that was needed. So we didn't implement it. It's possible that there is a use case out there that needs it, in which case the mechanism is already described. We just couldn't find it. So to be able to do that then, to support RTX, FEC, and RED, instead of doing a double encryption of the packets, the end-to-end encryption is going to be an encryption of the media only, right? And so this is what is described here. What we do, we don't take the packet entirely. We remove the header, the extension, and the padding. We remove the extension and the padding. We keep only the header and the payload. maybe removing 1 byte for optimization or something like that. And we're doing the encryption of that. And then we put it back in the original packet, right? So that's done when you have the payload. And then once you have that, you can apply RTX red effect and everything you want. The reason why it's important, for example, to support RTX red effect is that the media server, usually a good SFU, will protect the quality of the call by buffering some of the packets, so that if one of the remote peer is on a very bad connection and is dropping packet as a very high packet loss, the SFU will send in the packet again instead of returning to the source, to the Unix source, and ask the source to re-emit the packet, right? So that way, you don't have a noisy neighbor effect. That's what I understood, right? That's it. If you don't understand that, I'm no help to you, and you can come on the mailing list of the working group and ask more details. This is what it looks like. I know people love this ASCII heart with this and everything for the headers of the RTP packet. It's something that some people relate to. So here it is. And I think the idea is you have no change in the way you handle the RTP packets. You have no integration with key manager required really in the spec. So most of the other documents couldn't allow you to cherry pick one. We wanted the double encryption without the tunneling and without the key management, right? That was not really possible the way it was originally written, even though in practice it is. So we proposed a way to do that. The only thing you have to do in an SFU to support that is support the frame marking extension. And only 3 parts in the document: the start, the end, and the iframe. That's it. Okay. Now, of course, Janus doesn't do simulcast and SBC, so that was enough for them. But Jitsi supports simulcast, so you need to have the index of the layer to be able to handle that as well. It looks like there are some problems with the VP8 picture ID in the payload, but that's a WebRTC global problem, another problem here, right? So this is what happened on the receiver end, right? To be able to reconstruct the thing for those who want to be thorough, and that's the idea. So we have a draft under construction that is unfortunately for the time being on Meetup, but we're waiting for information or to nicely put it at the disposal of the working group. We have an open source implementation of a modified libWebRTC that is based on Chrome 57. Actually, we also have one that is based on 60. You have here the libWebRTC, and for those that are just interested in testing and don't want to deal with recompiling Chrome, which I totally understand, we have also pre-compiled binary of Chrome with a key that is automatically set, so you can test the double encryption with the different servers. Right? So you just can send an email to us, and we have access to the binary for tests if you want. GT has it. Janus made it available this morning as a pull request, so anybody can come, grab it, play with it, and give feedback, not only to us, and by us I mean Janus team, the GT team, and myself for the client, but of course the PERC organization on whether this is useful and address your own problem. I think that's the slide. Yes. So if anybody has a question, I will try my best. No.
Explain how it wrote red RTX goes on, but then it's not broken.
If you use the original proposal, if you do a double SRTP, it's broken because if I understand correctly, RTX red in fact are payload type in their own, and so if it's encrypted, you cannot change the payload type. But if you only encrypt the payload itself, then you can change the payload type of the packet, and the SFU can then replay it by modifying what it needs to modify to make it a full slash, whichever it is. Yes, Ryan.
So the only reason for the double encryption is just because the bridge is expected to do at least one decrypt?
That's the use case. The idea is what happens if you don't trust the media server?
What if it encrypted it once but didn't have the bridge didn't have the keys and all the information is in the extension or something anyway? Then the bridge would just have, I assumed it was just so it didn't have to change the bridge to know not to do a decrypt sometimes, because it normally does.
You have to, the way it was written, you have to. So the frame marking is supposedly allowing to undo that, but then the modification you will have to do is more complicated on the bridge. You have some case where you allow it, some place where you don't allow it. Right. And if you host your media bridge on the cloud, and if you don't trust it, you just don't trust it. Right? So if you suppose from the beginning that you don't trust this entity, that anybody can go and tell your ISP, I need access to that server, give me all the data, give me everything. The only way to protect yourself is by encrypting your data and not give access to anybody between the sending and the receiving. So there's a lot of things you could do on a media server not to do, but if you don't trust it, you don't trust it, right?
But I'm saying you could have encrypted once, not given the keys to the bridge, and then just told the bridge, you don't even bother trying to decrypt the media. Everything you got is just going to be in the decrypt.
That's true. No, that's true. You can do that. But then you have to replace WebRTC entirely. The advantage of these is that if you disable it, then you fall back to normal WebRTC. It comes on top of the existing WebRTC with absolutely no modification of WebRTC itself. So we think it's a more elegant solution. So we cannot really ask people to just forget about WebRTC or modify the TLS SRTP or things like that.
So I'll help answer this a little bit. Well, I'm not the expert on this. We really want Adam Roach for that. The one reason you need to be able to have a encrypted connection to the central server is so that the central server can do things like take simulcast input and then subset and grab the right pieces of that, forward them on to the other pieces. If it's fully encrypted at the source, you can't.
Right. This still would require the header, the frame marking.
Right.
Well, I think the bigger problem actually is more like what you're proposing, like one end-to-end key works nicely for like two parties. Then basically your server in the middle is almost like just a turn server, basically, just forwards just packets. Right? But what about like if you have three people, right? You would basically the first endpoint would start basically sending its detail as client hello, and the server would forward it to both of the other endpoint 2 and 3, and suddenly you would get back like two DTLS handshakes from two different clients. What do you do?
Well,
then?
yeah, I was assuming you would leverage the key server that the end-to-end one is already used, but I think it's pointed out.
Then you're like really
not do DTLS or something.
Then you're like really in the business of like doing SDS again, which like the whole ITF like completely rejected and said like, no, we're not going to do like key management outside of
protection, and then you go and support that.
The key distribution part of it is tricky and non-obvious.
Yes.
And also having the central server being able to monitor some parts of the RTCP code such that it can respond to things like NAC requests for the packets in the central server, and such that a NAC request doesn't have to go all the way back to the source, for example, and the central server can. So when you have a NAC, instead of having to go from here back to there, back to there, back to there, it just goes like this.
Yes, that was not part of Dr. Alex. Like the current spec, the RTCP so just goes to the server. Yeah. So that one doesn't go end to end. So that allows what Arnaud was just describing. That like basically, if the server, for example, like is missing a packet, you can go to the originating client and say, like, okay, give me that one packet again, please. Because
RTCP just uses
so that's why that
the
part
RTCP is hop by hop only.
Yes, that's what I wanted to say. You need that part to be hop by hop only. Otherwise, there's a lot of mechanism in SFU that really improving the quality you cannot use anymore.
Right. I mean,
and that's where the discussion between should we do end by end for everything or not, and so on became complicated.
So we are talking about one encryption versus two. So it seems very lightweight. How lightweight it is? Do you have measurements in terms of the overhead of the increase of size and increase of CPU usage?
Yes. So we did the scientific evaluation. So Jitsi had counted all the bits and everything. We have that. I don't have that in my slide here, but I can pass the paper with the full thing with you. It was almost negligible in terms of size. In terms of CPU, though, you almost double the encryption cost. It's almost twice the same cost. And so with the current elliptic curve SDA that they use in Chrome, it's between 5 and 10% of the total cost. So it's small, but not that small.
So what I would say is the encryption this generation of
yes,
that's relatively expensive. However, that's not done on a packet-by-packet basis.
Correct.
The packet-by-packet basis is an AES CBC encryption chain block, and AES on blocks of these sizes isn't that expensive. I think the last time I looked at it in the profile for single encryption, and would be roughly double for this, it was on the order of 1% or 2%, maybe.
Right. Okay. That's the order of magnitude. So again, there were a lot of effort made on the key generation time between 2013 and now in WebRTC, and especially on mobile. Yeah, in our case for the second encryption, and that's per stream or per connection.
Yeah, that's when you start, when you do the client low and
right. Such. In our case, it's different because the key are generated and maybe pre-exist in the key manager, so that load is not on the client.
Yeah.
Right. And anyway, it's small compared to the encryption itself. That is not,
the encryption itself, not a big deal.
Not anymore.
Yes.
So you said you had a Chromium implementation.
Yes.
So how would you pass these keys?
Yes. So we had discussion with Peter and Taylor, who are the guys doing that right now. In our first naive implementation, we percolate the key all the way from the peer connection constructor down the pipe. So we extended the RTP parameter dictionary that we pass to the constructor to add not only the media, not only the key, but the crypto suite that you actually use, because you need that both. They don't like that design very much. What we're going for right now is something that is going to be attached to sender and receiver. So because the WebRTC 1.0 spec is locked, frozen right now to pass it through the pass line, for the time being, we will document that a new API in the WebRTC spec, because it's a community group and not a working group. So we have less normative pressure.
WebRTC.
WebRTC NV. Well, we don't speak about that yet. We'll wait for TPAC and we will decide with the group. But that's not a discussion we can have right now with W3C. So we do an implementation in Chrome right now that is based on undocumented and reference API for the time.
Just
sure.
On is there anything beyond RTP header extension or inclusion of an RTP header extension that's needed by a client to advertise if it wants this extra capability?
No.
So it doesn't need.
But the difficulty was to implement the double encryption. That diagram there is not easy, and it comes at two different places in the WebRTC.
No, I think he's asking like on the.
Does the client need to advertise to the SFU that he's using?
But yeah, like the header extension is only for frame marking, right? That's like kind of like even independent. You can even advertise supporting frame marking even on your regular call if you want to. Right? It's like a prerequisite for a protocol. But you can even like that basically does not advertise that you want to do a protocol.
In your case, in your own implementation, you had a double flag somewhere?
No, I think like basically you would need to, I guess like in your case, it's like implicit through the whole call environment scenario. But like in like a web page, you would need to have like some way of saying like this service wants to do double calls, right? So like basically instruct the client to say like, okay, only double encrypted call is accepted.
As far as the media server is concerned, because it's transparent to it, as long as it can support frame marking extension, whether it's double encrypted or not, it doesn't even know about it, and it's just working.
Great, so it's just
opportunistic. But the client needs to know. So the thing is, the way we do it right now, we have one version of Chrome that is always on, and then vanilla Chrome that doesn't have it. So that's how we do. We do not really signal anything in specific way. That we would need a mechanism for that. Good question.
Also occurs to me that,
extra question.
It also occurs to me that secure recording could also be a byproduct of this mechanism. That's what he was recording all the packets.
Yes, so we actually enhance the Janus record and replay plugin, and we can do encrypted recording. And so you record the media as an encrypted media, you can replay it, because you can change the timestamp and so on and so forth, and you only decrypt it on the receiving side, whether the receiving side is in real time or later. So we have implemented that as well.
Or you do it as a separate participant in the conference, basically.
Right, but in that case, well, this is what GC do. They have a GBE server, which is after the client, so after the decoding and the encryption and so on. But then you do not, you break the encoding. Right? So you better store it on premises, on the client, and so on. What we did with Janus is that you record on the server side, which is not trusted, but that's okay because the media is still encrypted. Nobody can have access to it unless they know which key was used. There is an additional problem, of course, is because it's not real-time media. There's a file somewhere that was encrypted, and you're giving a lot of time to people to have a brute force attack to the encrypted file. So it's a little bit weaker than the double encryption with real-time media, but it's still better than, you know, encrypted, you have the raw media, then you record on file.
I think from my point of view, actually, the bigger problem is that that recording is only valuable if you have like a pre-shared end-to-end key, which the solution in the working group are like
you have a way to retrieve the key, but that's the key manager.
Well, but like in the case of what the working group proposed with the key management server, it's like the dynamic key as your hop key. So therefore, you can't like then the media bridge basically can't do it. I mean, obviously it can record this stuff, but there's basically no way to get to that key later. Right. The key is not stored anywhere.
So that's the thing. The key in our case is not with the media server. You need to have the client. So you need the exact same condition of key access than you were in the time.
One of the clients that was in the call originally, and therefore had the key, would have to record the key, and then that client, in theory, could replay the recording.
Oh, like that's
one
given
way
for any call, right? Like any client can always.
Right, I know. I'm saying that's how you play that.
The thing is, and the reason why we didn't implement all the specificity of PERT is that the solution we propose for key management is a real solution. It addresses all the points you want to address, but it's not the only solution to address all of these points. So we want to give other people that have a different key management but that address all of these points to have access to double encryption without having to change all the key management.
Another topic. You made a comment about end-to-end header extensions not being supported.
We chose not to.
Right. And you said that you couldn't come up with any reason that end-to-end headers were required.
Yes, and we asked the question on the mailing list. Maybe my memory is failing me, but I don't remember having seen a real case.
Like nobody understood me. It's like a separate.
Well, I asked the question, you asked the question, but I mean, did you see any answer that was actually providing a use case where supporting hand-to-hand header extension was mandatory?
As I said, like we put it on the waiting list, and email responded saying like he doesn't understand what I'm talking about.
Okay, so we have one, and nobody understood what it was talking about. But
for example, if you're filtering out all the header extensions, you're filtering out things like the transmission offset header extension and so forth, which, while it's not mandatory, it'll work without it. It improves the bandwidth calculations being used and other things like that.
We do not plan to filter them out, but the original mechanism was putting a block on which one you can modify, which one you cannot modify, what was the respective and relative position in the list of header extension compared to the original one, the OHB, the original header block, and the new one, and so on. It was very complex for something you can do as well. all by hop. And the consequence of doing them all by hop and not implementing the complexity did not endanger the security of anything from our point of view. So we're not filtering them out, right? We're just saying you can do that hop by hop and it has no consequences. Why do you want to force a complex implementation and a complex solution with check everywhere for something that
I'm looking at the details. So you're not filtering them out entirely.
No. This is all about like basically where you put them and whether the server is allowed to modify.
Yeah, I'll let you in the work
don't worry about that. Yeah, and there's always the question of some header extension can have a different number, a different ID. Some of them are
that. So it's
right. So if you force end to end and the two ends disagree with that, or if you have several remotes that support the frame marking extension, by example, but with different ID, what are you going to do? So that was the Neil question, right?
You propose all the clients basically send out the 4,000.
So Campen was like, F them, they should support it. And Emil said, practically, I cannot do that. So I have to accommodate a little bit. So that means the SFU should be able to rewrite the ID of the extension.
With Emil, that's actually no problem at all, because Emil's implementation, the bridge is the offerer all the time, and the answer is not allowed to change the ID number. So
he was educated in French. What do you want me to say? Yes, an excuse. All right. Well, thank you, everyone.
No, I guess I need this one. Like at least prepared the. Oh. Survived. Okay, let's get this going. Yes. Doesn't really matter. Okay, so yes. Oh.
That's fine.
Okay. Let's switch this. Okay. Okay. So we heard before that developer tools are somewhat of a problem. So I'm just going to do a little bit of like give a history and like a little bit of a demo. So I ran into this problem that actually with the Jitsi video bridge we had some problems with Firefox. And I was trying to debug it, and obviously you can turn on all kind of logging like internally in Firefox, and then the Jitsi folks also helped out with like bringing up an extra instance of their bridge with extra logging on their end. But it was all like pretty messy, and what made me realize like, okay, I want something else here. Like I was looking with Wireshark at the traces, but that's only like so useful because all the media packets are encrypted, and so you see the first couple of bits are not encrypted. That's fine, but like as soon as you want to actually look a little bit deeper, Wireshark will show you something, but it's actually not the real thing. Like it's encrypted, and like Wireshark actually doesn't even know that it's encrypted. It will try to show you something, but the data is basically not trustworthy. So at that point, I decided like, well, this is going nowhere. So I basically added to Firefox a little extension. And I wanted to show you what I did there. So let's make this a little bigger. We go. Basically, what you need to do is you export two variables. One is called the Moz log file. And the important piece in here is at the end, the RTP logger. That's basically the new logging module. And when Firefox sees that environment variable, it basically turns on RTP logging before encrypting the stuff and sending it, and in the opposite direction, when it receives a packet, it will decrypt it and then write the decrypted packet to the log file. Then in case of Firefox, you need like a second variable, which is the log file, just to instruct it where to write that log file to. And then what you can do is you just like start your Firefox. Oh, okay. Never mind. Whatever. Okay. So, and just for the purpose of demonstration, I will just go to one of our test pages. And do the typical, just like two peer connections connecting to each other. Hello. This is not going to be super interesting, but for the purpose of the demo, it's hopefully good enough. So if I close now Firefox, and I could do this also in the background, doesn't matter. I mean, I could leave Firefox running. Now, in this case, we actually have, like we see actually several Moz log files. That's because E10S is on the multi-process support. Depending on whether that's on or not, you either get like multiple log files or like just a single one. So if we take a look into that, as you see, like 4 of them are actually like 0 size, so they're not. Not very interesting, but in this last log file, you will notice these like lots of hex dumps basically, and that's the RTP logging. That these are like the RTP packets in raw, not encrypted anymore. And then there's like a nifty long command which basically grabs out these hex dumps and feeds them into a text to PCAP. And that basically converts these hex into a PCAP file. And now we have like here a nice PCAP file, which I can load into Wireshark. And there you have all the RTP in clear text, not encrypted anymore. Let's see if I still have it in the copy buffer here. There we go. Now you can do things like, for example, search in the RTCP for a NAC. Well, this was just a test call over loopback, so there was no missing packets. Therefore, there are no NACs. But in the blog post, which is also on the blog Jan-Ivar used before, there's like basically hints on how you can search for PLI. So basically, the request of saying like I want the whole iframe. Or this one is the one for like searching for like NACs. I'm just missing a single packet. So yeah, that's the whole thing, the whole demo. Hopefully, it's useful to someone. Any questions? Oh, maybe one thing I forgot to mention is currently what. Let's see if I can show it real quick here. If you look at the bottom here, you will notice that most of the packet is actually nulls. So currently it's logging only the first 8 bytes and then replaces all of the rest with zeros. But we're probably going to make that a little bit longer because what you can actually do, I don't know if it's, I would have to find the setting, but basically there's like there's a setting where you can tell Wireshark which codecs you used. If I find now VP8 somewhere at the way down, there we go. Huh. Did it actually? There we go. Actually, right. So you need to go in these settings and tell it like what payload type number was used for a given video codec. Like because it doesn't have I think like if you do it with like a voice over IP SIP call, it basically learns that from the signaling. But in the WebRTC call, your signaling basically will not be in your trace, right? Therefore, it doesn't know the payload type. So you need to manually tell it, like in this case, VP8 was using like 120. And then you not only see like the RTP header, but you see the VP8 header also being decrypted. And the reason I'm probably going to extend the amount of bytes I'm writing there is that there are like certain use cases depending on the payload where like you need more than just 8 bytes. You probably need like, I don't know, I think we discussed like 16 or 20 or something like this. I think you even suggested to drop it all together. But.
Well, I mean, the biggest reason for not having some sort of limit is just to reduce the amount of overhead in the log file and log file size. There's no true privacy issue here. This is basically a developer thing you're doing.
That's true. Yeah.
So the only reason the limit is to keep the overhead in size or CPU for writing log down.
Yeah, we could also cut it by after some bytes. Or
if you let the whole thing there, then if Wireshark understands the codec, it could like play back the audio for you, or I don't know, video, but certainly play back audio for you.
I don't know if we can do Opus, but.
But you can at least decode it to a font, decode the whole thing to a file.
Yeah.
Anyway, doesn't matter. And just at the point, you are including the entirety of RTCP packets, right?
Yes, the RTCP packet are for them. Everything gets the whole thing gets locked. There's no cutting off of any information in there.
The codecs usually you don't need CPAS before, but the rare exceptions might be something like H264 staff packet, where you might.
I think that was the
subheaders that are scattered in the packet.
Right. Yes.
So how would you enable that in an environment where you can't control environment variables? For example, Sauce Labs or Browser Stack?
We haven't like really looked into it.
We don't particularly. We cannot have something like this be accessible from
the UI. Yeah. Well, what we
so
would.
I was thinking like Selenium will let you do switches, but not environment variables.
We can put it like.
It could, in theory, be exposed on a command line switch.
Either that or like a user pref. Yes.
Of course, you can always make a stub executable that takes command line switches and turns into environment variables. So basically,
we wrote down some pretty terrible paths trying to get OpenH264 running on Sauce Labs. Right? It was not practical. And it was like the same environment variable.
Yeah, I mean, the reason in general, Firefox avoided adding 1,000,001 command line switches. I know Chrome has more than we do. Mostly, for things like this, either done it from within the browser in the bug config or whatever, or from this. In theory, we could consider putting it on a bug config, but I'd be a little cautious about that. Yeah, I certainly wouldn't want to be so. I would want to be one that isn't saved. If we did that, since it wasn't permanent. It would always dump in your.
Oh, you mean like reset it basically at the end of? No. Well, I mean, there's like.
Reset it to off at the start of when the browser starts. You could go in there and change it and turn it on, but it would be off.
But I think for automated testing, you actually need to be able to load it from a profile, or actually, well, I don't know. We will have to. Well, we're open for improvement suggestions, basically, and it sounds like there's room for improvement. Yeah. Yes, like all of this is in a blog post. Blog Mozilla WebRTC, which is the same blog as Jan-Ivar used already earlier for his talk. Here's like his blog post, and the one I was going by is here, March 15th.
We We use the same.
And there's like the environment variables and also like the nifty command to extract it from the log file and like what you need to find the stuff in Wireshark.
We use the same trick for jumping to a Wireshark compatible file for debugging data channels, or debugging the SCP links. We dump the SCP data directly and then Wireshark out. That's where we got the idea of doing this right here.
Yeah. All right. That's it. I think we have like 15 minutes to get out of here. Especially
so, like I said, we've got most of the core WebRTC teams for
yes.
Firefox here. So buttonhole us if you have questions.
Let us know. Talk to us. File bugs. And please test on nightly. I always need to say that wherever I go publicly, do not test on beta or release because we won't be able to help you.
And don't forget, now we have nightly, beta, and release.
There's no Aurora. Dev edition is dead. Long live nightly.
There is a definition that's mostly for tools. It's version beta right